The broadcast is now starting. All attendees are in listen-only mode.
Hello, good morning. I am Cheyenne Eloy, and thank you for joining our webinar on how to keep heat transfer fluids and free oil out of your power plant wastewater with TiPSS technologies. I'm here with Ham, and we're going to start in 2 minutes. We just give a few minutes for a couple more people to join, and then we will begin. Okay, I think it's okay. Yes. Okay, so next. So these are the webinar rules. Basically, the webinar is recorded, and everyone is in listen mode, so you will not be able to speak. If you have any questions, feel free to use the question box at the right in the drop down of GoToWebinar platform. Of course, feel free to ask questions during the webinar. We have a Q&A session at the end of the webinar where Ham will answer all your questions. Next slide. So the agenda for today, Ham is going to give you a little bit of background about MPP systems, as well as how they're part of Veolia Water Technologies. We're going to touch on the challenges and drivers of the power plant industry and how TiPSS technologies plays into this as with the CPI. And then we're going to deep dive into the oil separation efficiency with the TiPSS CPI technology and how it's applicable for free oil and HTFs. And then we're going to look at the latest success stories in Dubai and Egypt for solar power plants and a thermal power plant. Before we begin, next slide.
Yes.
Yes, thank you. So before we begin, I just want to do a quick poll to answer this one question. What is the biggest challenge with your power plant water treatment system? So I'm going to launch the poll now and you just select your answer. We have okay. Okay. Thank you for the responses. All right, and if we look at the results, so 44, I mean, it's a bit of a tie, but 44% of people said meeting regulatory effluent requirements is a big challenge. And we're going to see how, again, how TiPSS plays into this and how you can meet strict regulatory requirements with our technology. And then selecting the right technology for treatment. So we're going to look at TiPSS, but we're also going to explore complementary technologies from Veolia Water Technologies that can also be used alongside TiPSS for power plants. All right. So Ham, I give the floor to you to begin.
Yes, thank you, Cheyenne, for the introduction, and thank you all for joining this this webinar. My name is Harm Unk. I'm with Veolia Water Technologies for over 12 years now, working with MPP Systems. It's a subsidiary of Veolia Water Technologies, located in the middle of the Netherlands in Ede. And we are specialized in de-oiling technologies. So MPP Systems has more technologies One of them is the TiPSS tilted plate separator systems, as we're gonna discuss in this during this webinar. The other technology is, for example, MPPE. It's an liquid extraction technology to remove dispersed and dissolved hydrocarbons from LNG wastewater. And we have the CoaFill. It's a new disruptive technology to remove oil, free oil, and other emulsified oils from wastewater applications. So in this webinar, we're going to zoom in on the TiPSS tilted plate separator systems. We are not only delivering equipment, we can deliver turnkey installations. We do partly installation, commissioning, and startup as supervising or just with field engineers. We have an after sales department, and we also can provide some pilot plans to run some pilot tests in the industries, new build plants, brownfields, greenfields. Our technologies are applicable to all kinds of industries, not only power plant, but where there's oil in the wastewater, we can remove it with our products. And it's good to mention that we have over 30 of projects done over the last 5 years. So very busy with projects, and it's still a technology often used in the industry. Let's see if we can go to the next. Yes, our markets. We are targeting 5 regions of markets: Europe, where we are located, of course, Middle East, Southeast Asia, South America, and North America. So we have local offices, all those places. We are, as MPP Systems, part of a techno BU, so technology. But in every country, in every region, there is also a local selling BU, which have the knowledge of our products and can help you with more customized or demand on your questions on the wastewater technologies. So we're looking at the TiPSS technologies. We have a portfolio of more products, a little bit standardized. First of all, the classic CPI for oil separation, a light feed of solids concentration that's below the 250 milligrams per liter. We have the crossflow CPI. It's also a CPI separator, gravity separator, but the main flow is crosswise of the oil flow, so, and the solids flow. So this means that the solids are not dragged into the effluent, so you can bear a higher solids load and be able to separate it with a big and a good efficiency. And the last is the pressurized CPI, used for in-process applications, but also for wastewater applications, upstream, downstream. Where there's pressure in the water, you don't want to lose this pressure and to pump it out again, feeding it with energy. So to use the gravity in the separation process, we can use a pressure vessel with the separation internals. Drivers and challenges and drivers. Factors affecting wastewater and treatment in power plants, where we are focusing on this in this webinar. If we're looking at the coal and for the power plants, we see in the graphs, in the trends and the trending, that there will be a decrease till 2030 because of the exhaust challenges, the regulations, but also the water use. The power plant is a system with the steam boilers for the coal application, where you use a lot of water compared to the other technologies. So a lot of water has to be reused or to cleaned before you can use it as, for example, the boiler feed water. As we're looking at the natural gas, we see a stable and long-term investments on these projects till 2040. 75% on water per megawatt compared to the coal installations. So that's a good alternative for coal. And of course, we have also the solar plants of thermal solar or other kind of solar renewable energy plants. For these plants, we also an increase to 2040 for total projects for over the 100,000 megawatts in projects. Regarding the recent and upcoming regulations, we choose two examples for the regulations. One is from the Spain area, and the other one is the government of Dubai, where we see that there are limits in the discharge of wastewater. And this is not only for those two regions, it's a worldwide, not a problem, but a worldwide regulation. Some of them are present in the wastewater from power plants, and the other ones are not that common in the wastewater power plants. So we have to make a distinguish between the effluent requirements for the power plants, for example, and for other chemical plants or other industries. When we look at the components in the wastewater, we see that the suspended solids and the free oil and fats are important and can be removed by CPI technology. There are different effluent requirements. In Spain, you see that 35 milligrams per liter for suspended solids and free oil and fat 5 milligrams per liter. As in the Dubai region, the suspended solids, free oil and fats are a little bit higher, but these are the discharge limits in the specifications for the sewage system. So I'm not sure in Spain if it's for the sewage system or after all at the end of pipe, but we have to be sure that we choose the right technology to meet the requirements for the wastewater overall. I have to mention that the benzene, atoluene, toluene, and xylane, the BTEX components, are often dissolved in the water, for example, for LNG wastewater or produced water. And this can, for example, be removed with our liquid-liquid extraction technology like MPPE. So we have also solutions for this. Veolia has over 600 solutions. So what are the global industry drivers and the challenges? Well, water scarcity. Everyone knows that water is becoming more scarcity even now. In Spain, it's very hot. In Italy, it's very hot. People are not allowed to wash their cars on the street anymore. Regulations are there temporarily, but it's a long-term problem. With water discharge requirements, if we look at the water discharge requirements as we have looked in the past slide, we see that it's more stringent, and it will be more stringent if there are new components found, like phosphor or the other components, then will be taken and incorporated in those requirements. The overall regulations, not only for the water discharge, but also for new build plans, for safety, environmental, for use of materials, building construction. We see that there are materials which are also not that good available on the market anymore. So we have to choose for alternatives in new build plans. The energy transition is a part of it. Because of the energy transition, you see also the shift from coal power plants towards gas-fired power plants or solar power plants. This is all related to the energy transition worldwide. And we know in Europe, for example, that there are goals set and to be kept for the environmental industry. And also the increasing energy demand, and that's why the picture on the right side is coming in. Because of the smartphone, the digitalization, crypto coins, of course, all kinds of energy consuming activities. People are using more energy every day, and it's because of that we need more energy and more energy plants. If we're looking at the upcoming projects suitable for TiPSS technologies, we have different regions where we have the statistics from the EIC database stream. In Spain, we have taken up to 50 projects, and we have selected only the bigger ones from 100 to approximately 500 megawatts. In Germany, there are 56 new projects coming in this period of 2022 to 2027. We see in Italy also 23 projects, also with the hydro, the wind, and gas-fired. In Poland, it's also nuclear there, CCPP, wind, and biogas as well. And also the Saudi Arabia region, where there are also gas-fired power plants new built, as well as solar and wind. So over to the oil separation efficiency with TIPS CPI. So CPI is standing for corrugated plate interceptor. It's an oil and gravity oil separation system. We can separate oil, but also the heat transfer fluids, which occur in the thermal power plants, for example. If we look at how does it work, CPI removal of oil and suspended solids, and also the HTF. It's a little bit on the technique of the process techniques of the CPI. It's a very basic gravity separation, and it's using the Stokes law for separation. And the Stokes law describes that a particle of a certain density in a viscosity of a fluid will have a rising velocity to the surface. This surface can be calculated. So with enough surface, you can intercept those particles. For example, if you have oil and water in one bottle, you shake it. It's like an emulsion. But if you leave it on your kitchen for 5 to 6 minutes or even longer, you see the separation in layers, and the oil will be floating on top of the water because of this density. If there was sand in the same bottle, you can see that the sand is settling at the bottom. So that's the sludge or the sand with the more heavy density. So what we are doing with the CPI systems is that we take this large rectangular surface and stack it in plates, each on top of each other. So we're using lamella plates, flat plates or corrugated plates to make the space, the plot plan space, as compact as possible, ensuring that the oil droplets are intercepted because they are all coalescing and hitting each other, making bigger droplets, and then has a higher velocity to raise to the surface. So in the right picture, in the middle picture, you see the reduced plan area. At the bottom, you see the long length and the increased surface area when you stack the plates on top of each other. And at the right side, you see that we have chosen the main phase, the light phase, the heavy phase. The main phase is the water, and the other phase, the light phase, is secondary, is the oil. So the oil will float towards the top of the water and then can be skimmed off, and the sludge will drag down to the bottom of the tank and will be separated there. So this is for all fluids with a density difference between the water, so the main phase, and its own density. So if you look at the formula, you can see that there's gravity, density, and droplet size together with the temperature and the viscosity of the fluid. This makes the CPI a very robust system. So we're looking at the type of oils. You can see where the TIPS CPI systems are applicable. The CPI is only applicable for removal of free oil and free particles like heat transfer fluids as well. Looking at the left side, you see the droplet size of the oil in microns. It's for the API, it's a rectangular basin. The API is a very old basic separation system. It's just a basin, like the bottle in the kitchen with the oil and water emulsion. The API works approximately the same, but takes a lot of plot plan space. If we look at the CPI, we can separate smaller droplets, but it's still for free and free separable oil. If we have emulsified or even dissolved oil or other components, then we need de-emulsifier, and then you go to flocculation coagulation with the flotation unit. Then you can separate it even to 10 to 20 micron in droplet sizes. Or you have the MPPE technology to remove dissolved. So you have the liquid-liquid extraction. Water is going through a particle, and then the oil from the water is going into the filter media and can be steamed out and reused after all as a product. So this is another technology for dissolved. We are now focusing on the free and separable oil because this is applicable in the power plant industry. When using, for example, flotation units, we have to dose coagulation, and flocculation can be organic or inorganic. This creates more sludge. So when you don't need to have this separation because there are no emulsified oils, then it's better to use a basic separation technology like CPI. So what is our value proposition for power plants and the wastewater? Well, we have over 250 industry references. We have done 30 plus projects over the last 5 years, but we are existing from 1940, 1950. So we have a large installed base on separation technologies. So we're gonna fit the customer challenges. If we look at the production and the compliance, the health and safety, we are able to meet those requirements and challenges for each customer. Out of the box solutions, we are linked to customer requirements often, and we can implement them, but we can also choose to alterate the design and to make it more custom made to comply with the requirements. So above that, on top of that, we have also the complementary technologies within Veolia. We have around 600 technologies. So there's always something we can add upstream of the CPI or downstream of CPI when needed to make it more efficiency. It's a proven technology and a proven performance. So because of this large installed base, we have a large operational performance feedback. And the feedback we got is that it's easy to operate. It's good customization applicable to it because it's a good modularization time. We zoom in later on this why it's modular. Spare lifetime is good because we also used to work in the oil and gas, so we have high quality materials. And it's optimized in operating cost because it's a gravity separation. You don't need the pumps in front of it. It's just gravity flow. So it's a really low operator intervention. And another example and key element is the sustainability. It has a small footprint. Even when you compare it to flotation or compare it to an API, it's very, very small because of the stacked and lamella plates. Water energy savings because of you don't need the pumps, and this saves energy consuming this. Also, there are no instruments needed because of the gravity flow. So we're working with static weirs and rotating skimmers by hand. So manual rotated skimmers. This don't need any energy. And also the sludge reduction because of this plate pack. So this will also minimize the cost. Because of no chemicals have to be added for removing free oil, sometimes it's better to choose the CPI instead of a flotation unit. So if we're looking at the product itself, you can see we have two types of standard units in steel basins or GRP basins, whatever is needed. It's very robust. It don't need it's very little downtime. Only the cleaning when it's clogged, if it's clogged, but the operational feedback that it's relatively never clogged and can be cleaned with a turnaround once in the 6 to 8 years. Works by gravity, so low OPEX, no chemicals required. It's a standard package, so we have quick delivery times. Even if it's 316L or another material, we can guarantee quick delivery times. And we have a high quality of internals, which are used to better oil resistance. And these are the components which are the BTEXs, which will sometimes affect, for example, polypropylene or polyethylene. It's not that resistant to BTEX, for example. Our plate packs are resistant to this in a certain amount. When we zoom in on the internals, this is one of the plate packs. You can see the frame. It's a 316 frame. We see that the construction is relatively easy, but also compact and robust. And we see the plates inside, the corrugated plates. Corrugated because of its shape, it's more mechanical strength, and the material is chosen to have this high resistance to oil materials. integrated lifting lugs, so you can hoist it out for cleaning if needed, and you can place it back very easy. It's not clamped, it's not screwed. You can just and don't have to unbolt it. It's just lying there doing its job, its work in the CPI tank. So looking at different applications, we also have the below ground. It's the same internals, only in a civil basin. We are no civil engineers, so we can help in the layout design of the CPI. We have a lot of experience in layout designs for CPI systems, even can advise on the hydraulic levels and hydraulic flows. The advantage is that this is underground level, so you can cover it up, don't have the vapors, it's can be connected to the sewer system as well. So we see this often in plants where there's a lot of runoff water contaminated with the spills of oils and the heat transfer fluids, and those can be separated easily with this CPI package. So it's also easy to operate a low apex because of these civil tanks. It's also good to connect to the sewer system, and we have unlimited possibilities of configurations using the standard modules. So if it's more flow, less flow, it's 45 degrees or 60 degrees for higher solid loads. All can be incorporated in the system. And that's the advantage of the civil system compared to the steel tanks. So achieving higher separations in your wastewater system for your power plant, how to do this? We have 5 ways to enhance oil water separations efficiency. One is the sludge management. So that's the regular sludge removal to avoid building up in the de-oiling system. This is done by vacuum trucks to suck out the sludge. It can be measured, can be there with a periodic interval. It can be designed with the sludge or sand catch basins in front of the CPI. It's easy to incorporate, for example, in the concrete structure. The other way is digital optimization. Veolia Watt Technologies use Aquavista tool to monitor the digital instruments on the packages. So if you have a larger water treatment line, will be able to benchmark it and to keep the optimal settings, regardless the operator controlling the system. You can also have always the good water quality at the end of the line. Also, of course, the predictive maintenance and the remote monitoring is a function of this program. Choosing for low maintenance. This is where it comes to choosing the right technology for the right wastewater. It's better sometimes to choose the robust and low maintenance options instead of the more complex systems. Because of the wastewater composition, we can always choose which technology is the best for your wastewater. Then we go over to the process design, the modularity, the flexibility of the design. We can accommodate maximum flows. We can also cope with some spikes or excessive runoff water, stormwater runoff. So if there is higher flow, the hydraulic flow in the systems can be designed to cope with the higher flows in case of flooding. Another example is the emergency weirs, which can be incorporated in the design. So when there's a lot of rain, for example, for 1 year and the rest is operational, we can catch the first flush with the high oil loads, and then the more clean rainwater, for example, goes directly to an overflow basin. So there are a lot of options where we can help and advise in the design. And at last, the emulsifying agents. Because of the technology of the CPI, it's to minimize the emulsifying agents in your cleaning regime, because CPI is able to just spray off with a water jet, a low pressure water jet, and then you can clean it already in situ. So you can leave the plate packs in the basin. Once they're at the turnaround, you can clean it. And that's the case for power plants, because there are not too sticky oils in the heat transfer fluids, and also the spillage of the other oils used in the power plant for maintenance or lubrication. Those can all be cleaned easily. So what we do have as associated services, spare part management, provide startup and commissioning spares, of course. We have the playpacks, we can assist you. We have a stock in the Netherlands with spare parts, so we can deliver out quickly. This will help also customers, well, that they don't have to keep for example, the playpacks on stock at their own facilities. Very space consuming, but we have them. Chemical services, when it's used to when there's emulsified oil and we have to break it in front of the CPI, for example, or another agent has to be a corrosion inhibitor, for example, has to be added. We have the Hydrox company within Veolia Water Technologies. They can advise you in all kinds of chemicals. And also the digital service, the upgrade. Upgrade is the all-in-one digital water management services, and it can monitor the whole plant. So everywhere where there are sensors, and there are sensors in water treatment lines, you can choose to have a digital service, and also have the advantage of preventive maintenance and benchmarking. So if we look at the complementary solutions for the power plant wastewater treatment, and wastewater treatment in general, Onyx Caldness, part of Veolia Water Technologies, has the MBBR. It's a biological treatment, is able to have some light oil as well, and Batex and toluene removal. So phenols as well. So it can the bacteria can be trained to cope with a light chemical load. So at the end of the wastewater line, when you have a biological treatment, you can have a robust and a relatively coarse separation of oils in front, and the biological treatment will do the rest. The Hydraflot CPI can remove, for example, the TSS, so the total suspended solids before flotation. Hydraflot is a non-oil and gas standard flotation unit, which is delivered by part of Veolia, and it can be helping to polish the effluent of the CPI if needed. And of course, Hydrotech disc filter can also be used to remove solids and oil from the wastewater. And for the high amount of TSS, we can use the CPI in front of this Hydrotech disc filter to protect it and to protect the bacteria on the discs. So over to our latest success stories of CPI power plants. We've done the Dubai Electricity and Water Authority, the DEWA Nor Energy 1 plant in Dubai. It's a thermal collector solar power plant. The objectives here was water reuse for service and cleaning. So we did a lot of CPI there around the site in all cleaning and runoff areas. Solution was the delivery of the GRP plate packs and the internals of the steel tanks, the classic CPI. So we have both systems combined. So it's all CPI, but we have on one hand the concrete basins, as you see here in the images as well, and we have the steel tanks also on site. In other applications where the water is on a higher level and it was under pressure already or pumped towards another destination. So there the steel tanks are applicable, and for the other ones we have the concrete basins. So the benefits for the client is removal of oil and solids during servicing of transformers and gensets. So in general, we also tested it on the right side with benefits. You see the image of an empty CPI with 2 plate packs, an oil skimmer, and a distribution baffle in front. This is working very well. They are tested them in front of the startup and commissioning. Well, if you look at the benefits and why they choose for CPI systems, it's a robust technology. It's compliant to the regulation in terms of effluent requirements, low maintenance, low operator intervention. You can leave the CPI as it is, and it's doing its job by skimming off the oil in the effluent skimmer. We have high quality internals, so they can withstand upsets of oil of different types of oil. Even Batex is a resistance to Batex, and it meets the effluent requirements, and that's of course important for a site to have the effluent requirements matched. So what's the performance of these systems? Each system has around a flow from 30 to 60 cubes an hour. The inlet of free oil theoretically was up to 500 milligrams per liter. We can guarantee effluent of below the 10 milligrams per liter. The droplet sizes for these calculations were based on the 60 micron droplet size cutoff. So because of the gravity separation and it's working because of the Stokes law, the droplet size is limited between 40 to 60 micron. The pH range is 6 to 9, and the plot plan space for one CPI was only 12 square meters. So it's a very compact solution. So if we look at the second case, it was the gas power plant. We did up to 5 gas power plants in Egypt. This one was for the Upper Egypt Electrical Company. It's called the Supercritical Power Station. For this one, the objective was to separate oil from water in 2 locations: the mazout fuel or diesel area and the water treatment area. So all spills, spills in the gas plant in the run of water contamination were treated. The solution was the classic CPI. You can see the steel tank there with some piping around it and some cables for the electrical operation of it. It's combined with some other technologies. And the benefits, of course, is the efficiency in the oil separation in a small footprint. If you look at the right picture, we see a rectangular steel tank with an operator besides it. The buffer tanks at the behind the CPI and an IBC on the right. You can see that it's relatively compact compared to the API system, for example. So the benefits for the client are the same as for the other ones. Robust, used also in Egypt, must be a low capex project. So that's important for the client. Veolia did the whole water treatment for the Upper Electrical Power Plant Company. So not only the CPI for the wastewater, but also the other water streams were there. The performance for this project, all systems were up to flow of 25 cubes an hour. But of course, CPI is not limited to 25. We start around 0 to 30 for one playback, one module. But we can have up to 750, even 1,000 cubes an hour or 1,200. It's up to how much modules there are in and what the calculation says. The inlet of the free oil was up to 3,000 milligrams per liter, so 3 grams per liter. It's very big, but the effluent was guaranteed on 5 milligrams per liter and the droplet size at 20 micron. So when I said the droplet size was limited to 40 to 60, when it's 20, that means that we have put in an over design with a more large surface area compared to our regular advice based on the effluent requirements to meet these 5 milligrams per liter. pH range also 6 to 9, and the plot plan space the same. It's as low as 12 square meters. So thank you all for attending this webinar, and we go over to the questions. So if you have any question, please don't hesitate to ask them in the question and answer session.
Hi, so if you have any questions, feel free to type them in the question box and I will read it out for Ham and he will respond.
Yes, Cheyenne, I see one question incoming to my. Is there a correlation between the influent and effluent parameters? No, there isn't. We can have up to 500, 5,000 or even higher load of oil up to the CPI, but it's not affecting the effluent guarantees because we are separation efficiency is based on Stokes law with the droplets and the calculation in density difference. Even with the higher oil load, we can meet a low effluent load. So it's not a correlation between influent oil load and effluent oil load, for example.
Okay. Harm, we have a question. Could you please explain when should a CPI or a DAF be proposed in an oil and gas application?
The CPI system is the core separation up to 10 milligrams per liter, and for free and separable oil. If we look at DEF, so flotation units, flotation units are more applicable when you have emulsified oil, because then you can dose the de-emulsifiers, coagulation and flocculation, which will make the oil de-emulsify. So it can be separated and catched with, for example, in flotation units with the air. So the micro bubbles will catch with help of the polymers, the oil droplets separated by the emulsifier. So it's free oil for CPI and emulsified oil, then you choose for the DEF system, flotation unit.
Okay. Okay, do we have any other questions? Harm, you had another question?
Can we use corrugated plate interceptor for other wastewaters as well? Yes, you can. CPI systems are used to separate oil and solids from wastewater in all kinds of industries and applications. It's used in process as well, but also for different types of wastewater. Not only runoff wastewater, but also desalted wastewater or produced wastewater. So yes, CPI separation is based on free oil droplets, but can be used to separate all kinds of particles when there's density difference between the particle and the main fluid. So yes, it can be used in different applications.
Okay, so we leave 2 more minutes for anyone else to ask any questions. No? Okay. I think that's it.
Yep.
Yeah.
We can finish.
All right. Thank you everyone for joining in on our webinar. Have a great day wherever you are in the world, and thank you again. Have a good day. Bye.
Yeah. Thank you. Bye bye.